I'm Don Mockholtz, and you are listening to Looking Up with Don. This is the Looking Up with Don podcast, episode number 105, for the week of January 5th, 2022. The related website for this podcast is donmockholtz.com. That is spelled DONMACHHOLZ.com, 2 H's. What's up in the sky this week? As our week begins on Wednesday, January 5th, the moon will be in our evening sky, a thin crescent. By next Tuesday, January the 11th, the moon will be 70% full in the evening sky. The midnight sky and the morning sky are still moon-free this week. This is a good week to look at the moon. What were you expecting me to say? This is a good week to stay in and keep warm? The moon reaches first quarter half-lit in the evening sky on Sunday, January 9th at 1810 Universal Time. On Wednesday, January 5th, the moon will be south of Jupiter. The planet Mercury is putting on a good appearance in our evening sky this week. Venus out, Mercury in. To find it, draw a line from Jupiter through Saturn and keep going. Mercury is along that line, closing in on Saturn by the end of this week. It will be low in the southwestern sky, setting about at the end of astronomical twilight. As the week begins, Mercury is brighter than Saturn by a full magnitude. By the end of the week next Tuesday, Mercury will still be brighter than Saturn, but only by 4/10 of a magnitude. We now know that the planet Mercury has a faint tail pointing away from the sun. It is made of sodium boiled from the surface of the planet. It has been photographed by amateur astronomers using long exposures in a sodium filter. Sodium emits light at this wavelength, 589 nanometers, which is 5,890 angstroms, yellow light. If you have a narrow band filter in this region, give it a try, even visually. Look for the tail of Mercury. Venus moves north of the sun and officially into the morning sky on Sunday, January the 9th. Comet Leonard continues to put on a good show this past week. It is now moving further from the sun and will never come back. Yes, it is leaving the solar system. Some comets do that. My first one did, and my most recent one, discovered in 2018, is doing that too. As seen from the Earth, it appears stationary this whole week in the southern evening sky. It is plotted on Podcast 105 Map 1, and if you want coordinates for it, well, here they are. Right ascension, 21 hours, 42 minutes. Declination, minus 36.3 degrees. Yes, it will be planted there for the whole week. It's actually moving straight away from us. The Earth was at perihelion on January 4th. That is when the Earth is closest to the sun as it gets all year. We are now moving slowly away from the sun and slowing down in our orbital speed around the sun. The difference between our closest point and furthest point from the sun is only about 3%. So you're unlikely to see any difference in the brightness or size of the sun. As for weather, that is more dependent upon the declination, north or south of the equator. That results in a higher or lower sun angle and more or fewer hours of sunlight. That's how the sunlight affects your weather. Looking ahead to the rest of 2022. Last week I discussed the eclipses of 2022, 2 partial solar and 2 total lunar eclipses. The 2 total lunar eclipses are May 15th, 16th, and November 8th. Now for the planets. The big planet event of the year is the opposition of Mars in December 8th, 2022. That happens every 22 months, and for Mars, it really makes a difference whether it is close to us or far from us. Venus will be in our morning sky for most of the year from January 9th, which is this week, through October 22nd. Then it will pass into the evening sky. Mercury, the planet closest to the Sun, will wag back and forth several times this year between the evening and morning sky. Jupiter will be lost in the evening sky in another month and will emerge into the morning sky in April. It will reach opposition on September 23rd. That is when it will be closest to us and up all night long. In the last part of this year, 2022, it crosses the equator 3 times, ending up north of the equator by the end of the year. Saturn, the ringed planet, will be lost in the evening twilight in a couple more weeks, and it passes behind the Sun on February 4th. It will then be visible in our morning sky this March. It reaches opposition on August 14th and will then spend the rest of this year in our evening sky. Next week, I'll discuss the prospects for comets in 2022. Will you be able to see the International Space Station this week, which for our purposes begins Wednesday, January 5th through Tuesday, January 11th? It depends upon where you are located. This week we have 6 zones. Now all you need to know is your latitude. If you live north of 57 degrees north or south of 31 degrees south, you will not see the ISS this week. That is, as you head towards the polar regions, north of 57 degrees north, south of 31 degrees south. From 40 to 57 degrees north, the ISS will be in your morning sky for the first part of this week only. From 30 to 40 degrees north, it will be in your morning sky every morning of the week. And as we move further south, from 15 degrees north to 31 degrees south, the ISS will be in your evening sky for at least part of the week. To determine where you can see the International Space Station and a whole bunch of other satellites, go to the website heavens-above.com and enter your location, then click on ISS. 3 comets, comets 67P, 19P, and 104P, will be in a line in our evening sky on January 14th, all within 16 degrees of a straight line. You'll need at least a small telescope to see them. This week, even though they'll all be in a line, we do have the moon to contend with. So we'll wait until the moon is out of the sky to highlight these 3 comets. This week, before the moon enters the midnight sky, let's highlight 3 comets rising after the moon sets in the evening. One is periodic comet Phae, also known as 4P/Phae. We have been monitoring that one now for several months. It is about 10 degrees east of the bright star Betelgeuse. Comet Phae is about magnitude 11 to 12. Next is Comet C/2019 L3 Atlas. It's near the stars Castor and Pollux in Gemini. At magnitude 9.8, this comet is big and it's far away. Okay, now imagine this. The distance from us to the sun is 1 astronomical unit. This comet is 3.5 times that distance away from the sun, and also it's 3.5 times that distance away from us. And at that great distance, it's still brighter than magnitude 10, so it must be a pretty big and active comet. Once again, that's C/2019 L3 Atlas. It is at its closest point to the sun this week. Finally is Comet 67P Churyumov-Gerasimenko in the northern part of the constellation Cancer, rising shortly after sunset, and it's up all night long. It was closest to the sun 6 weeks ago, and is presently half the distance from us as is the sun. It is our brightest non-Leonard comet at magnitude 9. These 3 comets and others are plotted on podcast 105, maps 1 and 2. For more detailed real-time positions and maps, go to heavens-above.com and click on Comets. There is a Netflix movie out now entitled Don't Look Up. So why does a podcast entitled Looking Up with Don talk about Don't Look Up? Listen, Don, do you want us to look up or not? Well, the movie storyline is about a long-period comet that is on a collision course with Earth. I have not seen the movie. We do not have Netflix, and we seldom watch anything on TV. But I have read about the movie, including reviews and statements from the cast and crew. First off, government-funded search programs look for asteroids that might hit us. And they have found a lot of asteroids, but none is expected to hit us within the next 100 years. Asteroids orbit the sun, usually every 3 to 8 years, and astronomers can calculate the orbits for decades in advance. They do that for short-period comets too, as they are fairly predictable with their orbits. Long-period comets are different. They come in from any direction, and typically there will be several months from the time one is discovered until it reaches our vicinity. Secondly, if any comet or asteroid is on a collision path with the Earth, word would get out rapidly. Both amateur and professional astronomers, most not connected to any government, can produce the orbit of any of these objects and predict where they are headed. I personally know amateur astronomers who monitor such things. Finally, the icon image for the movie Don't Look Up has a similarity to the icon image used for my podcast, Looking Up with Don. That was created by my wife 2 years ago. Maybe the movie makers said, "It's good enough for Don, so we'll use it too." So at face value, the movie Don't Look Up is said to be a comedy of a comet that is headed toward us. Watch it and enjoy the drama and comedy. Meanwhile, the director and cast of the movie say that the movie is about, well, wait for it, climate change. I am not making this up. Once again, Hollywood uses a fictional story with satire and comedy to push their viewpoint on you, the customer. This has happened before and will continue to occur as long as people take them seriously. I have finished adding up all the statistics for my comet hunting in 2021. I now know how many hours I visually search for comets. In podcast 97, 8 weeks ago, on November 10th, I predicted I would end the year with between 170 and 180 hours. This follows my strongest year in a long time in 2020, when I searched for 224 hours. 2020 had good weather, and I did a lot of hours. 2021 had some bad weather, and my hours are fewer. So how many hours of visual comet hunting did I do in 2021? Take a guess. It's more than 180. What's that you say? 189 hours? Exactly right, 189 hours. That took 122 sessions. I have now done 8,939.5 hours of comet hunting since I began on January 1st, 1975. I count only the time that my eye is to the eyepiece, and I'm sweeping the telescope. This is a more stringent standard than some of the other comet hunters. Also, I have been comet hunting for 47 years times 12 months, which equals 564 consecutive months of comet hunting. Not a gap, not missing a calendar month in 47 years. I don't think any comet hunter in history can say that. My least amount in a month is 1.0 hours in December 2001. And the most number of hours I've done in any month is 69.25 in May 1976. Okay, there's two more things I want you to guess on in just a minute, so put your thinking caps on. I'm posting this information on an Excel spreadsheet this week. You can find it at my website. It's podcast 105, Comet Hunting Hours. There's two versions, one in Excel, and you can play around with the numbers there if you want, sort them, stack them, and so on, and one in PDF format. Each is 2 pages long. Okay, number 2. Guess how many telescopic meteors I recorded? It is between 300 and 400. So what's your guess? What is that? 373 meteors? You are right. In 47 years, my total is now 14,281 meteors. Finally, guess the number of satellites I recorded. Hint, it's more than last year when I saw 1,139 satellites. So what's your guess? Wow, you're good. You are right. 1,280 satellites I saw last year. I now have a total of 16,563 satellites in 47 years. This data is summarized in podcast 105, this podcast, the download sheet known as Meteors and Satellites. Download it and take a look at it. It is a PDF file. To recap the podcast, what's up this coming week? See Comet Leonard and Mercury in its tail. And time is running out to see Saturn and Jupiter in our evening sky. And don't forget the moon. You have been listening to Looking Up with Don, podcast episode number 105 for January 5th, 2022. I'm Don Mockles. Once again, the related website for this podcast is donmacholz.com. That is spelled DONMACHHOLZ.com. 2 H's. You can contact me at dontheastronomer@gmail.com. Once again, dontheastronomer, all one word, @gmail.com. God willing and pod willing, I'll be back next week for another episode of Looking Up with Don. We will discuss what's up in the sky and the comets we expect to see in 2022. All that and more. Thank you for listening. See the sky this week. I'll see you next week.